So when dealing with hydrogen ion concentrations and hydroxide ion concentrations, we are often dealing with numbers that are hard to comprehend and sometimes even harder to say. So a Danish scientist named Soren Sorensen developed a more convenient way of expressing hydrogen ion and hydroxide ion concentrations in acidic and basic solutions. He developed the concept of pH. pH is simply the negative log of the hydrogen ion concentration. Whenever you see that little P in front of a symbol, that just simply means negative log. So you can also take the POH. POH is the negative log of the OH minus concentration. So how does this apply to acids and bases? How can we use this? Well, if we take the equilibrium expression for water and we take the negative log of both sides, we can end up simplifying to get the negative log of H plus the negative log of OH minus equals 14, because the negative log of 1 times 10 to the negative 14th, which is a number that's kind of hard to understand, is just 14. That's a number we can understand. So then negative log of H plus is pH, negative log of OH minus is POH, so we can get another equation that can become useful for us when doing acid-base calculations. pH plus POH is 14, and then pH is the negative log of the H plus concentration, and POH is the negative log of the OH minus concentration. Let's take a look at some quickies involving these equations. Once again, these quickies only apply when you have concentrations of H plus or OH minus that are 1 times 10 to the negative something. So if you have an H plus concentration of 1 times 10 to the negative fourth, you can check this in your calculator, but that's simply a pH of 4. Okay, so if you know the pH, the POH is very easy to find. You just take 14 minus the pH to get the POH. So 14 minus 4 is 10. If the H plus concentration is 1 times 10 to the negative 7th, that qualifies as a quickie. The pH is simply 7. To find the POH, you take 14 minus the pH, which will end up getting you 7 as well. If the H plus concentration is 1 times 10 to the negative 10th, then the pH is simply 10. So the POH would be 14 minus that, the POH would be 4. So quickies work if the concentration is 1 times 10 to the negative something. If it's not that, then you have to calculate them. So let's do a couple examples where we actually have to calculate it. So what's the pH and the POH of a lemon juice solution that has a H plus concentration of 5 times 10 to the negative fourth? Well, if pH is the negative log of the H plus concentration, then we just have to plug in negative log of 5 times 10 to the negative fourth. When you calculate that, you get 3.30. And then, knowing that the pH plus the POH gives you 14, you simply have to take 14 minus the pH, and so the POH is 10.70. Human blood. If we know the H plus concentration is 2.5 times 10 to the negative third, what is pH and POH? Well, take the negative log of 2.5 times 10 to the negative third, and you get 2.60. To find the POH, you take 14 minus the pH. So in this case, 14 minus 2.60, you get 11.40 for the POH. Final example, what about baking soda if we have an OH minus concentration of 3.75 times 10 to the negative sixth? Well, in this case, let's find the POH. Take the negative log of 3.75 times 10 to the negative sixth, you get a POH of 5.43. Then to find the pH, simply take 14 minus the POH of 5.43, and you get a pH of 8.57. So if the concentration is not 1 times 10 to the negative something, then you have to calculate it using your calculator. What if you are given the pH and you want to know the actual concentration? Well, if you take your pH equals the negative log of H plus equation and solve it for H plus, you end up getting H plus equals 10 to the negative pH. So that is another equation we can use in our acid-base unit. We can also find the OH minus concentration by taking 10 to the negative POH. So let's try this with a few quickies and then one more difficult one. The first two, milk of magnesia and apple juice, are going to result in quickie type problems. We'll be able to use our KW expression. But if we know the pH for milk of magnesia is 10, then to find the H plus concentration, we simply take 10 to the negative 10th. So that means our H plus concentration is 1 times 10 to the negative 10th. Because of this, we can make use of the fact that the H plus concentration times the OH minus concentration is 1 times 10 to the negative 14th. Our exponents on our H plus and OH minus have to add up to negative 14. So OH minus has to be 1 times 10 to the negative 4th in milk of magnesia. If I use my pH diagram and look up 10 to the negative 10th for my H plus concentration, or a pH value of 10, you will see that it's on the basic side of the pH diagram. Apple juice has a pH of 4, so to determine the H plus concentration, you simply take 10 to the negative 4th, which ends up being 1 times 10 to the negative 4th. That means the OH minus has to be 1 times 10 to the negative 10th. That way our exponents add up to the negative 14th. If we look up our pH on the pH scale or our H plus concentration on the pH scale, we would notice apple juice is an acid. Well, what about saltwater aquarium with a pH value of 8.23? That isn't going to result in a quickie. If we take 10 to the negative 8.23, we get 5.89 times 10 to the negative 9th for our H plus concentration. So now we can get the OH minus concentration in a couple different ways. More than one way to cut your grass. One way to do it is to take the negative log of the POH. Since we know the pH is 8.23, then the POH is 14 minus that, which happens to be 5.77. So if we take 10 to the negative 5.77, we get 1.70 times 10 to the negative 6th. Now, we could also make use of the fact that H plus times OH minus is 1 times 10 to the negative 14th. And we could simply take 1 times 10 to the negative 14th divided by 5.89 times 10 to the negative 9th. We would get the exact same answer. And since a pH value of 8.23 corresponds to a base, we know that the salt water in the aquarium was basic. A few more problems like this won't hurt. So what would the H plus concentration of some apple juice with a pH of 3.76 be? Well, we got to find the H plus concentration when we're given the pH. We simply need to take 10 to the negative pH. So 10 to the negative 3.76 is 1.74 times 10 to the negative 4th. If you look at that concentration or pH on the pH scale, that corresponds to an acid. How about a solution formed by dissolving an antacid tablet and the pH of the solution is 9.18? What would the H plus concentration be? Well, once again, going from pH to H plus concentration is as simple as taking 10 to the negative pH. So in this case, 10 to the negative 9.18, which is 6.6 times 10 to the negative 10th. A pH of 9.18, or a concentration of H plus of 10 to the negative 10th, corresponds to a base. How about some milk of magnesia with a pH of 10.5? What's the H plus concentration and what's the OH minus concentration? Now there's a couple different ways you could skin your cat to solve this problem, but if the pH is 10.5, then the POH is 14 minus that, which is 3.5. So you could simply take 10 to the negative 10.5 to get the H plus concentration, and then you could take 10 to the negative 3.5 to get the OH minus concentration. Either way you look at it, the concentration of OH minus is larger than the concentration of H plus, which means that that solution is a base.